Walk up to your and the invisible physics that turn fire into freedom. To understand the genius of the automotive engine, we have to look past the macroscopic roar and focus on a single, hyper-isolated chamber of steel, the cylinder. Most modern cars have 4, 6, or 8 of these chambers stacked in a row or arranged in a sharp V shape. Inside each cylinder sits a heavy, cylindrical metallic plug called a piston. The piston moves up and down like a frantic fist trapped inside a smooth metal sleeve. This up and down motion is dictated by a strict, repeating, 4-step mechanical dance known worldwide as the Otto cycle, or more casually, suck, squeeze, bang, blow. The dance begins at the very top of the cylinder. The engine's mechanical lungs expand. An intake valve slides open at the top of the chamber, acting like a tiny gateway. As the piston drops downward inside the sleeve, it creates a powerful vacuum, pulling a highly combustible mist of fresh air and vaporized gasoline deep into the dark chamber. This is the intake stroke. The moment the piston reaches the absolute bottom of its stroke, the intake valve slams shut, sealing the chamber completely. The engine now prepares to weaponize the fuel. This is the compression stroke. It smashes the trapped air and fuel mixture into a tiny, hyper-dense pocket at the very top of the cylinder. This intense squeezing causes the molecules to collide violently, skyrocketing the temperature and pressure within the chamber. The fuel is now packed tight, unstable, and waiting for a single microscopic spark to unleash chaos. This brings us to the power stroke, the exact moment where chemistry transforms into kinetic force. Just as the piston reaches the absolute peak of its climb, a tiny device called a spark plug fires a high-voltage blue electrical arc straight through the compressed fuel mist. Instantly, the chamber erupts into a violent firestorm. The fuel expands with immense, explosive pressure. This expanding wall of superheated gas slams downward onto the head of the piston with the force of a sledgehammer. This downward drive is the only step in the entire four-stroke process that actually generates power to move the car forward. Finally, the chamber is full of spent, useless, and toxic smoke. As the piston hits the bottom of its explosive descent, an exhaust valve opens at the top of the cylinder. The piston charges back up for the final time, executing the exhaust stroke. It acts like a broom that sweeps the hot waste gases out of the engine, sending them down through the tailpipe and out into the atmosphere. The exhaust valve snaps shut, the intake valve pops open, and the entire loop resets to do it all over again thousands of times every minute. The four-stroke cycle is a beautiful piece of physics, but it presents a massive mechanical problem. The piston is moving in a straight vertical line, straight up and straight down. If you hook a vertical, punching piston directly to a car's wheels, the vehicle will simply hop up and down on the pavement. Wheels need to spin. They require rotational force, also known as torque. To translate a vertical punch into a smooth, high-speed spin, the engine utilizes the most critical structural spine in the entire vehicle, the crankshaft. Think of the crankshaft like the pedals of a bicycle. When you ride a bike, your knees push straight up and down, but your feet push against offset metal pedals that force the gears to rotate in a circle. Inside your engine, each piston is attached to a long, heavy metallic arm called a connecting rod. The bottom of this rod hooks onto a series of offset, weighted counter lobes on the crankshaft. When the power stroke slams the piston down, the connecting rod pushes against the offset lobe, forcing the heavy crankshaft to spin. Because a multi-cylinder engine has pistons firing at completely different, precisely calculated times, the crankshaft receives a continuous sequence of downward punches. One piston pushes down while another sweeps up, creating a perfectly balanced, uninterrupted stream of rotational energy. This spinning steel shaft exits the back of the engine block, passes through the transmission, travels down the axles, and ultimately forces your rubber tires to grip the asphalt and propel you down the highway. An internal combustion engine is essentially an engineered monster trapped inside a metallic cage. Left to its own devices, the engine will naturally try to destroy itself through two deadly, systemic vulnerabilities: friction and heat. Inside an engine running at 3,000 revolutions per minute, steel components are sliding against each other 50 times every single second. If raw steel touches raw steel at that speed, the kinetic friction will generate instant, intense heat, physically tearing the metal surfaces apart and welding the engine completely solid within minutes. To prevent this, the engine relies on a pressurized lubrication system. A high-pressure oil pump forces a micro-thin, slippery film of motor oil between every single moving part. The pistons don't actually scrape against the cylinder walls. They glide effortlessly on a microscopic cushion of chemical oil. This oil carries away tiny metal shavings, dampens mechanical shock, and ensures that the metal components never make direct physical contact. The second threat is thermal meltdown. The temperature inside a firing cylinder can easily reach 4,000 degrees Fahrenheit, hot enough to melt solid steel. To keep the engine block from liquefying, engineers wrap the cylinders in a hollow web of channels known as a cooling jacket. A water pump continuously circulates a specialized chemical mixture called coolant through these channels. As the fluid passes around the blazing hot cylinders, it absorbs the excess heat. The hot fluid is then rushed out to the front of the car into the radiator, where the rushing highway air cools it back down before it circles back into the engine block to steal more heat. It is a non-stop metabolic cooling loop that prevents a catastrophic meltdown. As you sit back in your car and listen to that engine idle, realize that you are experiencing one of the final chapters of a magnificent technological era. The internal combustion engine has shaped our geography, built our modern economies, and redefined what it means for humans to navigate space and time. Every single hum, vibration, and mechanical note echoing from beneath your hood is part of an intricate ballet of thousands of moving parts working in absolute, flawless synchronization to answer a single command from your right foot. The world is changing, and the quiet hiss of electric motors is slowly rising to replace the visceral roar of burning gasoline. But the mechanical brilliance of the piston engine remains an undeniable monument to human curiosity and innovation. The next time you push down on the accelerator pedal and feel your car surge forward, take a moment to appreciate the silent, raging firestorm happening just a few feet away from you. Listen to the rhythm of the crankshaft, respect the precision of the four-stroke dance, and smile at the wonderful, roaring engineering marvel that continues to power our lives. Till the next video, have a good one.